Hello and welcome to a special episode of From the Workshop with me, your host, Brandon Hart. We are here once again in the NimbleLink Nerd Lair, but this time we're doing something a little bit different. This time we are developing a 3-part IoT device developer crash course. We wanted to run through some of the ideas, some of the things that you need to know as a device developer who is planning to develop your IoT device and add LTE or cellular connectivity to it. So the first of these 3 videos will focus on background information, things that you need to know about cellular in general. And then we'll move into, on the part 2 video, we'll focus on hardware integration and really kind of the device development itself. And then in the third part, we'll get into taking your prototype to production. So without further ado, let's jump in on part 1 of the series. So first off, I think the fundamental question when it comes to developing an IoT device for cellular is, why develop an IoT device for cellular? Why incorporate cellular connectivity whatsoever? Why cellular at all? And I think the main answer to that type of question is all about the different alternatives and how you go about sending the data from your IoT device to the server, to the cloud, to wherever that data is going to go. And there are a lot of different alternatives, a lot of different options. You know, you could connect it to a Wi-Fi access point. You could use short-range radios and send them all into a gateway that's then connected to the internet. There's lots of different ways you can do that. But most of those other alternatives rely upon either a network that you can connect to or somebody who can configure it, somebody who can maintain that network for you. So you have to either bring your own network or manage the network yourselves. Whereas cellular doesn't have that problem. With cellular, first of all, you've got all these operators and carriers all around the world who are building out this network. It's what they do. And so they are managing the network. They are making sure that there is coverage wherever your devices may need to go, that the networks are the highest quality, that you'll get the best signal, that the newest technology is implemented, etc. They're also building security into those networks. So LTE networks are fundamentally encrypted and secure over the radio layer. So there's nothing you need to worry about in terms of security over that initial connection from your device into the cellular network itself, which is obviously a relief. Not only that, but again, they're deploying these things all over the place. Cellular networks are ubiquitous. They are almost everywhere these days. And so you don't really have to worry about whether there's going to be a connection wherever you're going. In addition, a cellular radio inside of your device can be pre-configured. So your device, during the manufacturing process itself, you can turn the radio on, you can activate the radio, you can test the radio, and then you can just put it in a box, ship it to wherever it's going to go, and it's already working. It's already ready to go. Maybe they plug it in, maybe they pull a piece of plastic out to allow the batteries to make a connection, maybe they hit a power button, whatever it is, but you've already configured the LTE or cellular radio inside of the device. It's ready to go. So you don't have to depend upon somebody with expertise locally to deal with that. And these devices are going to, again, report directly from the device to wherever you're trying to go. So you don't have to worry about trying to set up anything in between. So a lot of different reasons why a lot of the device developers out there are looking to LTE and cellular technologies to connect their devices and send their data. Okay, so with that being said, how did we even get here in the first place? How did we get to LTE? Is LTE 4G? What is 4G not as good as 5G? Should we all be trying to look at 5G now? And let's just take a step back and figure out where all of this came from. So first there was analog, or I guess you could call it 1G now. And then there was 2G. which, obviously 2 is better than 1, so that must have been much better. There was CDMA and GSM. Then we moved to 3G, which was an evolution of CDMA and GSM, so HSPA, UMTS, and EVDO and those types of things. But then we got to LTE. And at that point, LTE was the one technology to rule them all. And LTE was what everybody deployed, starting with LTE Category 3. But then something interesting happened. After we all came together at LTE Category 3, there was then a diverging path from that point on. So there was the bigger, faster, stronger, better, more throughput, more power, more datas being sent through stuff so that your phones and laptops and things like that can send all the data they want. And then you had devices like our IoT devices that really didn't need all that. We needed occasional connectivity, we needed low power, we needed low cost, we needed simplicity in the radios. And so a whole different path was created, which is the MTC path, or machine type communications path, where we kept getting simpler and simpler and simpler, eventually leading to things like LTE-M, or LTE Category M1, as it's sometimes called, and then NB-IoT, or NB1, and then NB2. And these are low power, wide area technologies, or LPWA technologies, that are really meant to optimize for low power and low cost. So that kind of got us to where we're at right now. So on the high end, there's Cat 16, 17, 18, 19, whatever. And then on the lower path, where most of us are working, is this LTE-M, NB1, NB2 type of path, where we're really trying to focus on keeping the cost down, keeping the power down. So that kind of gets us to where we're at. So what about 5G? Well, 5G takes the next step beyond those things. So 5G is on the upper path, is going to give you things like gigabit internet connections, crazy, ridiculous speeds. And then on the lower path is going to give you things like massive machine type communications, where thousands of these devices can be communicating over thousands of nodes in thousands of places all over the place. So every grain of sand can have an internet connection if you needed it to. So that's kind of, again, sort of following that path. So that's how we got where we're at. The same path is being followed all around the world. So in some places you'll see NB networks that are primarily deployed or exclusively deployed. In other places you'll see LTE-M networks that are primarily deployed. And in a lot of cases, like here in the United States and North America, we're seeing both of them deployed over top of each other. So you can have your choice as to what makes the most sense. So around the world, we're seeing lots of different deployments, and global is becoming something that is much easier to do these days with radios that are capable of connecting over all the different LTE bands that are available. Which takes us to how you connect to those things. And there are a few different radio types that you'll have to choose as a device developer. There's always the chipset level at the lowest level of things. The chipset is what's actually compliant with those technologies and is responsible for doing all the low-level connections and talking to the cellular network and making all that stuff work. But then you have a chip that then goes into a module. That module adds an applications processor, maybe a GNSS radio, maybe a software layer that provides special AT commands and special functions and network stacks and stuff like that. And then that module then goes into an end device. It could be straight into an end device, or it could be something like a NimbeLink Skywire modem, which is the end device that you can then put in your final device design if you want. But the main reason why there are these three categories is because each one of these three categories relates to a level of certification. Yeah, certification, everybody's favorite topic. But you have to understand that a chip has to go through certification. So you have to have an approved chipset to work on a particular carrier or on a particular part of the world. Then that chip, that approved chipset, goes into a module. The module then has to go through its own level of certification. That certified module will then be put into an end device. And yes, there is one final level of testing and certification that happens at the end device level. So you as a device developer have to look at these options and determine what makes the most sense for you. Are you going to deploy millions of devices? Are you going to deploy hundreds of thousands of devices? Are you going to deploy tens of thousands of devices? It's all up to you to make that determination. We couldn't possibly get into everything that goes into choosing the right radio, but we do have other videos that you can check out that will get a little bit deeper into that. So see below for the link on that. So we're going to cut it off there for part one. We'll get a little bit deeper into the different radio options as we get into focusing on the hardware that you're going to use to develop your IoT device and add the LTE connectivity to it in part two. As well as talk about a few other things related to the hardware design and the hardware development itself. So with that, please do like, subscribe, check out the GSMA website, check out other from the workshop videos down below. Shoot us emails to workshop@nimblelink.com. Leave your comments, all the YouTube-y things that you're supposed to do. And we'll see you in part two. But until then, have fun building.